Hello everyone and welcome back to chapter 6 of the Actix Web Rust tutorial, and today we're going to be looking at middleware and how it can be used in your application. So middleware is basically a fancy name for a special function that pretty much hooks into your application state, allowing you to pre-process and post-process requests and responses, modify application state, and access external services such as Redis or your database or logging services, and also hold requests from happening. Let's go ahead and look at the first example on how to do this. And we're actually going to be using the built-in middleware called Logger in Actix Web. And it's really pretty simple. You simply initialize the logger with the from env logger package, and you can use it right here by adding it to your cargo toml. And then you basically want to wrap your application in this logger. And when we start up this application, you can see that we'll get some logs. So in the previous tutorials, whenever I started our application, there was no logs, and Actix Web simply omits them unless you enable logging. And if we change the log level to debug, we should see some more information in these logs as well. Okay, it looks like we don't, but that might just be because we don't have any services actually running that need the debug information. Okay, so when I actually shut down the server, you can see that we have a paused accepting connections debug info right here. So the debug is actually working. If I go back up to when I first ran this command again, you can see that it was in info mode and there was no debug logs. So Actix does actually provide debug information in some places in the base library. I haven't ran into all of them, and I personally haven't used Actix Web too much recently, so I kind of forgot when that's actually hit. But yeah, let's get into the second thing that I want to show you guys, and that is the wrap fn function. So let me clean up. Okay, I actually need to clean up some of this code real quick. Remove this logger, and we need to implement the service traits, or just import it, I guess. Okay, so basically this wrap fn function allows you to create a on the fly, doesn't really have a name, middleware function that can sort of mutate your request. Now, right now, it's pretty much happening on the root of the application. So this will be ran on every single request for any route. And I kind of see this as a really easy way to sort of create a middleware prototype without having to fully implement the transform and service traits. But it is really handy that you can simply append a middleware like this and write some logic. All right, now we're going to look at how to implement a custom middleware. So this will be a logging middleware service that is going to show us information about our requests that are hit on the server. So if we start the server, we can see no logs, and I simply remove the built-in Actix web logger. That way the logs would be super clean and we can understand what's going on. So if we go to our browser and refresh and go back, we can see that we got a custom get to root and the response status was okay. And so, yeah, I know this looks like a lot of code, and this is just, part of the verbosity of Rust, but once you understand how everything works, it's actually really easy to understand how everything's happening. So we do have some implementations on this transform trait, and we also have an implementation on the service trait. And we will need to create a custom service to basically handle this middleware logic. And so the transform trait, you can think of it like a factory trait that pretty much creates the middleware instance that Actix Web is actually going to call. And then the service trait is actually what processes the request. And understanding these two traits is key to building any middleware in Actix Web. Um, so the transform trait, it takes your service from your route handler or next middleware, and it wraps it with the proper middleware behavior. So if we actually look at the code, we can see these types, right? And these types basically tell um, ActixWeb what type of data your service is going to be working with. And so this is where you can implement, your own custom types as well. These are sort of just the default values. But here we have something important where we say the transform type is the custom middleware. And this is the type we define down here. And this will be the type of our service. And you can see that we're using a lot of generics here. And this is so that we can pass in the correct types for the service when we actually pass it around. And it just makes things a little bit easier as well for the implementation. You can kind of just ignore all of this, honestly. This is just defining like, S is going to be type of service request. The response is going to be the built-in Actix web service response, and the error types are Actix errors. So, and then the future is going to be static, which basically just tells Rust, hey, the lifetime of our service request is going to exist until the future is um, satisfied. And making it static just makes sure that it complies with the Rust memory model of ownership and borrowing, and how you can't have a lifetime that ends before the scope that it's used in. So static just makes sure it exists during the duration of the program. Um, and then we also have this custom logger struct, which simply satisfies the transforms trait. So there's not much really to do and look at in this trait. It's mainly just literally a foundational type for the actual service request. And you need this new transform function. And this ready function basically tells Actix Web, well, you can see the little comment right here, create a future that is immediately ready with a value. And the value we're passing in is the custom logger middleware, which again implements the service. And like I said before, this is just a builder for the Actix Web engine to know how to call your middleware. Now, if we look at the actual service type, we can see that the service type has a similar. So if we look at the service type, we can see that it has a similar structure to the transform with the type assertions. And if you're not familiar with Rust, also this little where statement basically says that S and B have to be of at least implement these types as well, or else they can't be used. So just for some extra type safety. And here we have the response, which is the type of middleware. Sorry, the type that the middleware returns, which is the same as the inner service. We have the error that the middleware returns, the future that the middleware returns, and this is a future that will resolve into a response or an error. And the box pin dynamic basically allows us to return different future types. So it's kind of a generic for futures as well. And since it's using box, it will be on the heap as well. The poll ready function is called by Actix Web to check if the service is ready to process request. This is basically a part of Rust async runtime, and it allows Rust to pause our code when busy, so that we can, allocate resources and stuff. And then here we simply delegate the inner services poll ready to check if it's ready. So that's why we do self.service.poll ready. It's sort of like a wrapper function, really. And then the call function is where the actual middleware logic happens. And it's basically called for each request to our server and returns a future that will return a response. And so you can see here, we're getting the request information from the service request type, and we're getting the path and method. And that is basically the same log information that you guys see down here. And it's all being given to us dynamically. And that is really the core of the logging middleware, and middleware in general in Actix Web. You can go a lot deeper and add a lot more functionality. For example, in authentication, you can do a call to Redis inside of here. You are able, as you see here, to use async. So there's a lot more things you can do here. It gets pretty complicated, but hopefully that was a somewhat easy to understand explanation of how all of this crazy code works. I know people are going to look at this and say, oh my God, Rust is so ugly, but this doesn't look any better than C++ templates to me personally. So the next thing I want to show you guys is how to use cores. And this isn't really like super advanced or anything, but I just figured I'd mention it in this middleware sort of chapter because you're probably going to run into some cores errors inside of Rust and basically any API that you're making external, and they're just a pain in the butt to deal with. So this example by default just kind of enables and allows anything, which I guess isn't technically a good sort of security model to follow, but I personally just like to do this in development, just enable everything because I don't really like cores errors. And once your API is fully finalized and everything, you can sort of, deny everything, I guess, and only allow whatever you need. But for iteration, just enable cores and forget about it. So I wanted to show you guys really quick a real world example of middleware. And this is kind of similar to the GitHub authentication example in the last video. So you can see here we use headers inside of this call action and actually check the header existence and sort of validate it. And against the secret token, we can accept this request and proceed to the handler, or if there is no header, then we can simply return an error. So you would kind of implement this like this, have your route, your get to public, and you can attach a service, which would be this slash API, and you can wrap it in this middleware and protect it. So the public routes won't be affected because they're outside of this service scope. And yeah, this is just another example of how you would actually implement a header-based bearer authentication sort of example. One last thing to remember is that middleware order matters. And when you wrap multiple middleware, they execute in the reverse order. So cores, logger, and handler will actually execute first, even though you might expect the logger to execute first since you defined it first. This is just one of those quirks about Actix Web that you'll have to figure out. And with that, we've pretty much gone over all the core concepts in loggers that I want to cover in this chapter. If you actually do want to dive deeper, feel free to look at the Actix Web examples and explore more. So thank you guys for watching. In the next chapter, we'll actually look at database integration and how that works.